Mr. Frederick here again, ready for page 3 of the midterm review, the SAT questions. We're going to start with number 12 and work all the way to number 17. All right, ignore any students asking questions, just focus on my voice. Here we go, number 12. It says if 20 minus x is equal to 15, what is the value of 3 times x? So I think the easiest way to do this, the most straightforward way, is to solve 20 minus x first. Okay, so if we move the 20 over, it's going to be 15 minus 20, which is negative 5. All right, so if the opposite of x is negative 5, what is x? 5. All right, so x is 5. All right, just joking, okay. 3 times x then would be 3 times 5. So 3 times 5 is 15. So C is the answer for number 12. All right, let's move to number 13. Number 13. What form of the quadratic is this written in?
Vertex form.
Shh. Come on. It's vertex form. All right, it's vertex form, which means that when we're looking at this, we can immediately find the vertex. So what is the vertex of this quadratic? It is 3 and a. Remember to think opposite inside the absolute value, inside the parentheses. Okay, so the vertex is 3a. Now, how do I know which way it opens? How do I know which way it opens? Excellent. You look at the very beginning, you'll see that there's a negative sign, so it's going to open down. So when I sketch this, it's going to open down. So the vertex is up here, 3a. And if that vertex is at the very top of your parabola, that's called a what? A maximum. So the answer to this is that its maximum occurs at 3, a. Questions on 13? Excellent. Good work, students. Let's keep going. Number 14. Okay, number 14, I have yet to figure out a really quick way to do this. So if you guys have figure it out or have figured it out, let me know offline. But for now, I'm going to show you the way that I did it. It gives you a table of x and y and says there is a linear relationship between x and y. So my first thought is if it's a line, then there's going to be a slope and there's going to be a y-intercept if it's a line. Okay? The formula for slope is the change in y, so y sub 2 minus y sub 1, over x sub 2 minus x sub 1. All right? You guys know from the students that are not really here that from when we did this in August and September, I just choose the first 2 ordered pairs. Okay? So I choose a and 0, and I choose 3a and negative a. That's what I chose, okay? So my second y value is going to be the opposite of a, minus my first y value, which is 0, over my second x value, which is 3a, minus my first x value, which is a. All right? So if you do that, you'll get negative a over 2a. Okay? So simplifying that gives you negative 1/2. Right? Because the a's cross out and make 1. So negative 1 over 2. Are we okay? Okay, great. Now, in order to find the y-intercept, what I do is I write down slope-intercept form, so mx plus b, and I replace m with the slope of negative 1/2. Okay? So I'm going to write down negative 1/2 x plus b. Okay? Now, who remembers what to do when you get to this point? How do I find the y-intercept? You don't plug in a 0. You go back to the table, okay, Fernanda? Actually, I only need 1 point, but it contains 2 things. Very good. So which one do you want to use? There, me too, right? So I'm going to plug in for x, I'm going to plug in a, and for y, I'm going to plug in 0. Okay, so y we said is 0, and what did we say x is? Is a. Okay? So that means if I multiply negative 1/2 times a, I get negative 1/2 a plus b. So what is b equal to? What is b equal to? If you move the negative 1/2 a over, what is it equal to? Positive 1/2 a. So my equation in slope-intercept form is y equals negative 1/2 x plus 1/2 a. And I look for my answer. And why don't I see my answer? Do you know how the answers are written? Standard form. Very good, Natalie. All right, and so they're not written in slope-intercept form, but we can change this very quickly. The first thing I notice is that I've got fractions here. You guys see how I have fractions in my slope-intercept equation? I'm not against fractions, but look at the answer choices. Do you see fractions? No. So here's what I did, was I multiplied everything by 2. So that gives me 2y equals, if you multiply negative 1/2 times 2, you get negative x, right? Because the 1/2 times 2 is 1, so negative x plus, and what's 2 times 1/2 is 1, so you get a. So if I move this minus x to the other side, what does it become? If you move to the other side, it becomes positive x plus 2y equals a. And I believe that answer is a. Again, I've yet to find a quicker way to do this. I'm sure there's one out there. My brain is just not seeing it yet. All right, but that's the way I did it. So just to recap, I know it was a lot of work. To recap, I found the slope. Then I found the y-intercept. And then I basically manipulated my slope-intercept form to become standard form. Questions on 14? How did I get B? So are you good on how I got the slope? Okay, so I wrote down my slope-intercept form and plugged in the slope for M. And then using Fernanda's idea of taking an ordered pair of x and y and plugging it in for x and y, I solved for B. So she chose A and 0 for her x and y, but she could have chosen any of the other points. So that was this algebra here. It's a little funky, Amy, because the y-intercept is not a number, it's 1/2 times A. That's why it's a little weird. Okay, let's do 15. Now, 15 is a calculator one, so if you have your calculator, you can get that ready. We have a system, and it says, what is the x-coordinate for the solution, the intersection, of this system? Now, when I look at a system, I always ask myself, what do I think is the fastest way to solve this? Right? If it's substitution, then usually they're going to give you like y equals or x equals. Are they giving you y equals or x equals? No, both of these are in standard form of a linear equation. So most likely it makes sense to do elimination. Now, I noticed that this coefficient of y and this coefficient of y, I can actually multiply this second one times 3, and I'll get 1.5y. And I like that because what's the coefficient of the one above it? Negative 1.5y. So when I add those, I will eliminate the variable y. Okay? So I'm going to write down 2.4x minus 1.5y. I'm going to enlist your help, please. What is 3 times 1.6x? 4.8x. I know this one is going to be negative 1.5y. And then what's 3 times negative 1.3? Negative 3.9. Joelle, question? Did I hear something wrong? It would be positive. Absolutely. You're totally right. Thank you, Joelle. Any questions on this? All right, now remember, it's my preference to make them opposite signs. Do you have to make them opposite signs? No, I just like to use addition. All right, so I'm going to add straight down. I'm going to eliminate the y variable, so that's gone. So that's going to give me, I believe, 7.2x equals negative 3.6. So if you divide both sides by 7.2, you'll get x equals negative 1/2. All right, and they've got that as a. What do you want? No, okay. Now, as I was doing this problem, I realized that every single number in the problem had a tens place. So if you wanted to do this without decimals, just multiply everything by 10. Then it would be 24x minus 15y equals 3. So if you wanted to like eliminate decimals, you could. Questions on 15? Let's keep going. The next one, 16. Now, 16 is one of those problems where they're asking you in the end to take a value for x and basically evaluate this expression. But ultimately, what I think most students will do here, which I agree, is just to solve for x. Okay? So if you multiply 9x minus 6 times 2/3, what do you get? Not. I think it is going to be 4, because if you do 6 times 2, you get 12. 12 divided by 3 is 4. There's another minus 4. Okay, so that's going to be 6x. There's the 8. Now, it's your preference on how you want to do this. All right, I'm going to move the 6x to that side to get negative 8 equals 3x minus 6. And if you move this negative 6 to the other side, by adding 6, you get negative 2 equals 3x. So x is, very good, negative 2/3. Now, that's not the answer. All right, so you'll probably, it doesn't surprise you that you'll see students put C as the answer. Right? So that's why they put C as an answer choice, because you solve for x, found it. But it says, what is 3x minus 2? So you're going to multiply, so 3x minus 2. You're going to multiply 3 times that number, and then subtract 2, which will give you negative 2 minus 2, which is negative 4. So A, not C. All right, and the SAT, as you guys have noticed this semester, and they're doing these review problems, they love doing that. The SAT loves writing questions that is solving an equation, but then once you solve for it, then it wants you to do something else with it. Okay, so just make sure you read the whole problem for that one. Questions on 16? Okay, let's do one more. 17. Okay. Again, I've yet to find like a simpler way to do this, so I'll just go with what I've got. It says we have an equation, and A and B are constants. So there's some numbers. I don't know what they are, but there's some numbers. And it says the equation has infinitely many solutions for x. What does that mean? What does it mean when you solve an equation and you find that there are infinitely many solutions? You guys remember what you should get when you're doing that, when you're solving? What do you get that causes you to think, oh, infinitely many solutions? I mean, no. Number on top of it is 0. That would be divided by 0. You can't do. You get something called a true statement. So you'll get like 6 equals 6. Right? That's a true statement. So if you get a true statement, you know that any value for x is going to make this true. All right? So if that's the case, then I need a times x plus b to be equal to what? I need it to be equal to 4x plus 10. The same thing. If this is true, right, if this is true, then I have infinite solutions for x. All right? Now watch this. Distribute the a. Okay, everyone distribute the a. You get ax plus ab equals 4x plus 10. So if this is going to be true, what is ax going to be equal to? Let me say that. 4x, right? See how they are in the same spot? So ax is going to be equal to 4x. And what about ab? Is going to be equal to 10. So ab is equal to 10. Now I can't do anything about a times b is 10, right? I can't do anything about that. But I can solve for a over here, all right? Because what happens with your x's? If I divide both sides by x, they go away. So a is 4. So if a is 4, when I swing back over here, if a is 4, then what does b equal to?
2.5.
Do we agree?
Yes.
Yes. 10/4. All right. Remember, this is a bubbled in one. So could you bubble in 10 over 4? I'm pretty sure you can. I'd have to look at the answer choices again, but I'm pretty sure you have 4 columns. All right. And you can do 1, 0, slash 4. I'm pretty sure that would work. All right. If it doesn't, now I'm going to be mad because 10/4 would definitely be right. All right. But yes, it would be 2.5. Most students would probably put that. Okay. That is 17. So the takeaway from 17 is that if it's talking about a linear equation, has infinitely many solutions, you're looking for a true statement. So whatever's on the one side has to be the same as on the other side. Okay? Tune in soon for page 4.